This is video 7. The main result was presented at the end of video 5. The path assembly considered in this theorem is simple and grows far away from the seed. In this section of the proof, we show how to find a segment of this path assembly which satisfies more hypotheses. These hypotheses are called macroscopic conditions and they will ease the study of a large path assembly. Consider a path assembly P producible by a deterministic tile assembly system. The path assembly satisfies macroscopic conditions if it satisfies the list of constraints which are on the left side of the screen. On the right side, we present a path assembly which satisfies these conditions. First, the path assembly is finite and simple. These conditions are natural since in the main theorem, we consider a simple path assembly. Moreover, this path assembly grows over a certain distance from the seed. Thus we do not need unnecessary information and we can consider a finite path assembly. We consider that the path assembly P has only one tile in common with the seed. Moreover, this tile is the first tile of P. Now, we want to work in the first quadrant of the plane. This could be done easily by setting the minimum ordinate of a tile of the seed of R of the path assembly to 0. Same thing can be done for the abscissa. This convention is called the first quadrant convention. Now, we are looking for a path assembly where the seed is near of the origin of the plane. The two following conditions are here to represent this constraint. If this condition is true, then the path assembly grows more to the east of the seed than to the west of the seed. Now if the second condition is true, then the path assembly grows more to the north of the seed than to the south of the seed. These two conditions are called the axis convention. Finally, we want that the last tile of P is higher than the bound B6. Now, we explain how to find a segment which satisfies the macroscopic conditions from a path assembly which satisfies the hypothesis of the main lemma. Moreover, if this segment is pumpable then the path assembly will be pumpable. This proof is done in 6 steps. The figure on the right side illustrates an example of this reasoning. First, we recap the hypothesis of the main lemma. The path assembly P is simple. The path assembly P is producible by the tile assembly system. This remark allows us to find a tile of P which belongs to the seed. The index of this tile is I2. The path assembly grows at distance B6 from the seed. This remark allows us to find a tile of P which is at distance B6 of the seed. The index of this tile is I1. Remark that we are here in a case where I1 is less than I2. This is the more complex case. We are interested in the segment of P which starts in P1 and ends in P2. This segment contains several tiles in common with the seed. We find an index I3 such that the segment of P between I1 and I3 contains only one tile in common with the seed, the tile P13. Now, consider the segment of from P from I1 to I3. This segment is simple, finite, contains a tile at distance B6 from the seed and one of its extremities is common with the seed. Unfortunately, this extremity is the wrong one. Then let's switch the direction of this segment. We obtain a path assembly Q which is producible by the tile assembly system and whose only common tile with the seed is Q1. Now, we are in the case where the path assembly grow more to the south of the seed than to the north of the seed. In this case, let's make a symmetry of axis X. We obtain a path assembly which grows to the north of the seed. Remark that this operation modifies the tile set in the seed. For each tile type, its north and south glues have been switched. Similarly, we are in the case where the path assembly grows farther to the west of the seed than to the east. In this case, let's make a symmetry of axis Y. We obtain a path assembly which grows to the east of the seed. Remark that this operation modifies the tile set in the seed. For each tile type, its east and west glues have been switched. Now, the path assembly Q satisfies the axis convention. Now, we focus on the first quadrant convention. Consider the dotted position. We want this position to be the position 0, 0. Then consider the following vector. By translating the path assembly in the seed, the first quadrant convention is satisfied. Now remark that the last tile of Q as an EBS is greater than B6 but its ordinate is lower than B6. Then we switch the X and Y axis and we obtain the following path assembly in seed. This final path assembly and this seed satisfy the macroscopic initial conditions. Note that we have modified the tile set in the seed but their sizes have not changed. Then if this path assembly is pumpable, then the original path assembly is pumpable.